In autumn 2007, Austria's largest bioethanol plant was commissioned by Agrana Bioethanol GmbH in Pischelsdorf. Agrana signed up Pörner Ingenieurgesellschaft as general engineering contractor to design and construct the plant. Oil and gas deposits are still sufficient, though the world's reserves are limited. For this reason, bioethanol plays a more and more important role also against the backdrop of the globally increasing energy needs. It is because bioethanol is produced from renewable sources and distinguishes itself by being an environmentally friendly and at the same time efficient fuel that makes an active contribution to climate protection because of its carbon dioxide neutral production. The Pischelsdorf plant produces approximately 240,000 cubic meters of bioethanol per year. Processed are wheat, corn and sugar beet syrup. However, not only bioethanol is produced, but also up to 144,000 metric tons of high-quality protein as animal feed, the so-called DDGS, that is produced of the residues. Pörner Ingenieurgesellschaft, with its headquarters in Vienna, was appointed as general engineering contractor to implement the plant. Pörner, with its 450 employees working at 8 locations, is well known as reliable partner in the plant engineering sector. The total investment value of this ambitious project amounted to 125 million euro. Pörner was responsible for providing the complete planning services. In the course of project development, and after having performed a feasibility study, a technology licensed from the American firm Katzen was chosen. After the technology was selected, the permitting procedure according to the Environmental Impact Assessment Regulation was initiated. After only 7 months, Pörner started to engineer the plant at maximum pressure. The scope of services included detail engineering, electrical and instrument design including process control system, civil and structural engineering supported by Pörner and partner Ziviltechniker GmbH, as well as planning of all heating, ventilation and air conditioning systems. Furthermore, Pörner was responsible for the overall project management, organized smooth site work and handled the project up to a successful startup and commissioning. Project manager Gerhard Wilczek and his team ensured that the project was executed according to the stipulated dates and budgets. Starting with a positive environmental impact assessment that was obtained from the authorities already 7 months after the application had been filled, Pörner engineers always kept the target dates by summoning all their strength. With the help of advanced software, the plant was designed. Thus it was possible to visualize the plant and get a clear picture of the plant at a very early stage. Planning and reality go together hand in hand. Intensive cooperation between all Pörner engineering departments and the specialist engineers at Agrana allowed for a very efficient project handling and almost just-in-time engineering. 3D PDS drawings that are laid over the completed plant show how precisely our engineers performed their work. A virtual walk through the plant was possible even months before the plant was set up. And after completion, it turned out the computer model and the finished plant exactly corresponded. Construction progressed extremely fast due to the very detailed engineering. It took Pörner only 10 months in total to build up the plant, starting with the first foundations till commissioning. A time-lapse film over the site over these 10 months show how the plant was growing. This could be achieved only because temporarily up to 780 people per day were working at the site. After all, Pörner and Agrana were pleased about the first schnapps in September 2007. Test run went off successfully. All parties involved could proudly look back to the great success achieved. The production of bioethanol is a high-tech process mainly consisting of 7 process stages. First, milling. The grain is led from silos via conveying devices to intermediate hoppers. From there, the feedstock is continuously fed into 3 swing hammer crushers working in parallel. Second, saccharification. In the next process stage, the starch contained in the grain is liquefied by enzymes as well as by adding water and recycled stillage. At the same time, a partial saccharification takes place. Then the hot solution is cooled down via coolers to fermentation temperature. Third, fermentation. In the fermentation stage, consisting of 6 fermenters, the partially saccharified mash undergoes saccharification as well as fermentation. In this process, the starch is converted into sugar and the latter one into alcohol by adding yeast. Fourth, distillation. After heating up, the mash is split into 2 partial streams and continuously distilled. In the so-called beer stripper, an ethanol-water mixture with approximately 50% ethanol by volume is stripped off. The mash, remaining in the bottom of this column, is pumped to the decanting station. The condensed distillate is led to another column where the high volatile products are separated before ethanol is stripped off from condensate and fusel oils in a so-called stripping rectifying column. The condensate is returned to the production process. The distillation product is the almost final bioethanol product. Only one more step is required: dehydration, where the water contained in ethanol is absorbed in molecular sieves. The final product is then pumped to 2 storage tanks having a capacity of 5,000 cubic meters each. From there, bioethanol can be shipped in road tankers or by rail. Fifth, solid separation. The hot, thin stillage coming from the distillation stage is fed into the decanting station where the solid matter is separated by centrifuges. Clarified liquid resulting from this process is returned to the liquefaction and saccharification stages. The residue is thickened in an evaporation station and is led as thick stillage to the drying stage. Sixth, drying. The decantation residue is led via screw conveyors into a mixer where concentrate from the evaporation stage is added. From the mixer, the product is transported to both dryer drums where the residue is dried to DDGS, that is in great demand as animal feed. Seventh, pelletizing. DDGS is pressed in steam-heated presses to pellets that are easy to handle. The pellets are temporarily stored in a bulk material storage. When designing the distillation unit, special know-how was required, since this unit is the heart of the entire plant for the simple reason that the distillative separation stage in this part of the plant provides for high purity bioethanol. A 3D animation illustrates complexity of all processes and the required engineering work. In September 2007, the bioethanol plant was completed. How ambitious this project was can be shown by the following facts. Pörner Ingenieurgesellschaft can proudly look back to the largest project ever implemented in its company history. In close cooperation with Agrana Bioethanol GmbH, Katzen International Incorporation, and Pörner and Partner Ziviltechniker GmbH, Pörner has made a substantial contribution to a clean environment based on state-of-the-art technology.